It's Monday, and today we are going to be talking about exponential and quadratic regressions. I have 4 examples. We're just going to do 2 quadratic and 2 exponential. I'm just going to show you how to do them on the calculator. Today I'm going to actually tell you which regression I want you to do. Tomorrow is kind of a review day. I'm going to give you linear, exponential, and quadratic, and I'm going to talk about ways to see which regression actually fits. Today I'm going to kind of preview that a little bit. I'm just going to show you this looks exponential, whatever. But I'm going to tell you what to do. So it should be a shorter-ish video. I'm hoping to have a shorter video and then be able to ask you several questions in the quiz. Okay, so let's go and get started. The table shows the number in millions in various years since the year 1950. I just stole these off the internet. I don't even know what the context of this problem is, but who really cares? I have years and I have number in millions. I'm going to go put this into my graphing calculator, or in your case, the online emulator. Whenever you're doing years, though, make sure that first year is 0, and then do whatever 1960 minus 1950 is 10, and do the math for all those guys. So these will just be, they're counting up by tens, and they're not skipping any years. All right, so we're going to go ahead and go over to the emulator over here. So to do that, I'm going to go to Stat. I'm already at Edit. I'm going to press Enter. I'm going to go ahead and enter this data. So I'm going to go ahead and pause and enter that real quick. All right, so I have entered that data, double check, make sure you paused as well and entered that data. All right, so on this question, I actually do tell you to enter a quadratic regression. So on these, for today, I'm going to tell you exactly what to do. Tomorrow, you've got to decide on your own. So going back over here, I've entered that. So I'm going to press Stat, and I want to go over to Calc, and it's very similar to linear regression. I'm just going to go down to LinReg. Okay, I'm going to go down, not LinReg. Today we're doing QuadReg, but I went down to LinReg. Okay, number 5 is QuadReg, so I'm just going to press Enter. Everything should already be entered. I am going to go ahead and store my regression equation. I do want to look at these things. Today I tell you what to do. Tomorrow you have to graph it first, and then look at it, decide what it is, and then tell me the equation. Today I'm just telling you it's quadratic, so just go do quadratic. But I do want to get in the habit of storing my regression equation, so go to vars. Go over to yvars, press enter for function, enter for y sub 1, and boom, boom, calculate. And that's it. That is my equation. So I'm going to go over here. My quadratic regression equation is going to be y equals. My a value is 0.01, 0.015. I guess I'll do 3 place values because that's kind of, that 4 makes a difference. Okay, that's x squared minus, this is going to be 0.539, and that'll be an x, and then plus 31.405. So you're going to take and just plug in your a value for the x squared, bx, and c. You're just going to plug those guys in, and that's your equation. The next question says, predict the year in 1987. So 1987 is going to be 37 years past 1950. We're also going to go ahead and also 1987 is within the data here. So it's in between 1980 and 1990. So the number should be roughly between 28 and 35. Maybe not perfect, but it should be roughly in there. But let's go ahead and also just look at this graph real quick. And we can kind of cheat on this guy. If you're ever doing interpolation, you can just use your trace function and find that value. So again, I've got to turn my stat plots on. So second stat plot, it's already off because I reset my calculator. I'm going to turn it on. Again, it's already set up for that stem and leaf. I'm sorry, it's already set up for that scatter plot. So just, you're done. Press zoom, press 9. And even if I didn't have this line graphed, it looks like a quadratic. It goes down and then goes back up. This is one that'd be really easy to be like, yeah, definitely quadratic. But now my line looks pretty good. It covers most of the points. There's only one point kind of hanging off. I do want to go ahead and just use my trace feature. And I'm going to press the down arrow key. So if I press over, I'm currently following those dots, and I don't want to do that. If I press the down arrow key, it gets me on my line. So now I can just move around on there. So I'm just going to press or type in 37, or use your calculator to do so, and then press enter. And I can actually see without having to do the math. Like otherwise, I would need to on my paper type in 37 in for x squared, 37 in for x, and you would just do that all in the calculator. It's a little easier if you're doing interpolation inside the data. Okay, so literally it's going to be 31.8. Tag on some unit, so I'm just going to go ahead and get large here. So 31.8, this is number in millions, so millions. And that's that guy. Okay, so when it's interpolation, pretty easy, especially if you're using that graphing calculator all the way. All right, next example, also a quadratic. I'm just going to go put my data in. It says the table shows the average number of daily hits for an online store in various years since the year 2000. They've already done the year 2000 as 0, 2002, 4, 6, 8, has all the values. So it's already set up. I've got a quadratic. I'm just going to go ahead and go over to my calculator and type in that data. So I'm going to pause and do that real quick. All right, so I've gone over here, I pressed stat, I went to edit, I put my data in, boom. All right, I did reset my calculator, so I'm just going to go ahead and actually look at this data first. So I'm going to go to second, I'm going to go to stat plot, I'm going to turn stat plot 1 on, press enter, turn it on. I'm actually just going to go straight to Zoom 9 right now so I can look at it. So tomorrow, you'll look at these, and this guy actually looks like he could be exponential or quadratic, and I'll show you tomorrow better how to do it, but this guy is not necessarily perfectly clear. So I did tell you to do the quadratic regression, so you can just go ahead and do that anyway, but tomorrow you'll sort of need to figure out some stuff on your own. All right, so go to stat, go to calc, quadrag is number 5, so go to 5, enter, 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 enter. I want to store my regression equation, go to vars, go over to yvars, go to function, press enter, y1, press enter, press enter, press enter. That's it. This is really easy stuff. Y equals, your A value is 0.9875. I might as well use all that, so there's only so many values anyway. And that's your x squared, because it tells you A is x squared. B is x, so plus 0.105x. And then C is just 0.92, so plus 0.92. All right, so I've written my equation, my regression equation. Now predict the year, the number of daily hits for the store in the year 2012. So 2012 is actually going to be 12 years past 2000. So I'm going to have x equal to 12, which is going to be outside of my data. So you could change your window and all of that jazz. Because again, if I just go to Zoom 9, I can see, ooh, that's very beautiful, quadratic. I can see the data here, but this only goes to the year 2008 and then maybe the year 2009 because my window is sort of going at 9. So if you want to change your window, you could do it, but I'm just going to go second, quit. I'm just going to type in my equation with the number 12 in for x. So I'm going to type in 0.9875 parentheses 12 parentheses x squared is this button here, boom, plus 0.105 parentheses 12 parentheses plus 0.92. So I just typed it all in just like you would on your calculator by hand. Boom, my answer is 144.38. Okay, so that answer is going to be, and this is in thousands, so just tag on the word 1,000 and then hits, or daily hits, whatever. So it's 144.38. Oh, I'm a little bit out of the window there. 1,000 daily hits. All right, so we're going to go ahead and go on to the next page. I'm going to pause. All right, number 3, again, I stole it off the internet, so I have no context, but I have some percent of population in a year. I tell you specifically exponential regression. So again, start out with 0 and then count your way up. Looks like there's no numbers being skipped, so it's just going to be straight up 4, 5, 6, 7. And I'm going to go over to my calculator. I'm going to go over to stat. I'm going to go to edit. I'm going to pause for one moment while I enter this data. All right, I just entered my data. Make sure you, when you do years, you always start with the first year as 0. I'm going to go ahead and graph this guy. Second stat plot, first stat plot, turn it on, and then press Zoom 9. Looking at this guy, hopefully you can kind of see he actually looks more exponential than quadratic. But again, today I told you specifically he's exponential, so you just do what I tell you. So I'm going to go to stat. I'm going to go to calc. Xparag is actually number 10. So I'm going to go down, what's number 10, which is 0 in this case. So you can just type in the number 0, or you can just click down, whatever. There it is. And hopefully by now, third example, you're like, I got this. This is easy stuff. I'm just going to show you one more example anyway, though. Store regression equation. I'm going to go to vars. I'm going to go to yvars. I'm going to go to function. I'm going to go to y1. I'm going to press enter, 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 all that jazz. And boom, that guy's done. My equation is y equals 1.487 parentheses, ooh, interesting, 1.488, close parentheses, raised to the x power. So don't forget that exponential is essentially your starting value and then what your multiplier is. And if you were to do this by hand, I mean, you'd just say your starting value is 1, which is, you know, obviously not perfect on that guy. And then if you were looking at how you got to it, you'd probably have something roughly 1.4, something like that. All right, predict the percent of population in the year 2015. Well, the year 2015 is going to be 2 years past this, so it's 9, so x equals 9. That's also going to be outside of my window, so I'm just going to have to go ahead and type this into the calculator. So I'm going to go ahead and do that. I am going to go ahead and first look at my equation just because I like to see how pretty it is when it graphs. Look at that, it's beautiful. Again, if you were doing something inside this interpolation, just press trace and figure it out that way. Otherwise, second quit, and I'm going to type in 1.487 parentheses 1.488 parentheses caret, and then we're typing in a 9. Okay, 53 point, and what is this, population, percent of population? So 53.18% of population. And that's it. These questions are pretty simple, especially if I'm telling you what to do. You literally just go do it. So our next example, use the table to answer the questions. So I told you already exponential regression. So I'm going to go ahead and clear my calculator, pause, and type this data again by going to stat and all that jazz. So I'm going to pause. And I'm back. All right, don't forget to clear your calculator. You just press second plus 712, or if you're using the emulator, go up to actions and press reset emulator. All right, so I would like to go look at this guy. So second stat plot, enter, enter, boom, zoom 9. So, ooh, this guy's a little messy, but he had a duplicate 3. So he does still look exponential to me. He's an exponential decay. Could also be quadratic, and again, tomorrow we'll discuss that more. So I'm just going to go ahead and go to stat, go to calc. Xpreg is number 0. I'm going to go boom, 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 restore regression equation by going to vars, going over to yvars, going down. By going down, I meant to say press enter yet again. Okay, boom, boom. Again, if you need to slow down and watch this again, you can. But it's the same stuff over and over. All right, so y equals 99.07 parentheses 0.68 parentheses to the x power. I have my equation. The question says find the output if x equals 6. Well, I'm just going to go ahead and zoom 9 so I can see this beautiful equation. And again, this one's not perfect, obviously. Looking at it, you could have told me that it wasn't going to be nice, but good enough. So I'm going to press trace, and I want to get off the dots by pressing the down arrow key to get onto the actual equation I wrote, and I want to find the output when x equals 6. I'm going to press 6. I'm going to press enter. The output is y equals 10.02-ish is good enough. All right, if I type in 12, it's not going to, oh, it's actually in the window. I'm going to just cheat and use that one. Normally, oh, because 11 was our last number. Normally, it only gives you one number beyond the window you currently have. So that worked out for us. Otherwise, just go back to second quit and then type in 99.07 parentheses 0.68 parentheses raised to the 12. It's going to give you the exact same answer. Obviously, okay, let me make a note on that and then we'll stop. Obviously, however you round these numbers, when you're doing the trace function, it actually uses every single digit. It's using all those digits. When you round, though, if you type this in by yourself, you might get a slightly different number, hopefully still 10.02, but you might get slightly number further than that. So obviously when you round, you become less accurate. So using the trace feature actually is the most accurate value. But, I mean, I'm not going to nitpick about a thousandths place value or something like that. So, alrighty, well, go ahead and do your questions on the Canvas quiz, and I'm going to specifically say, find a regression equation, find a quadratic regression, I meant to say exponential, whatever, you know what I mean. Find either of those guys, and then either interpolate or extrapolate, and that's it. So, hopefully, easy day. All right, see you guys later.